Not 2, 3, and 5.
Yeah. So I enjoying them once you've done it, and then you've done it for the day.
I'll hang around for the keynote because Mark might ask us to make comments. Or he might ask us to turn cameras on as well. Might just put a cap on or something. Go for a baby. What are you saying?
Your legs kicking and
Why? What for? I'm building a fucking spa in the bathroom. Why do you want to go to a spa?
like what, you getting like a masseuse and like someone to come and paint your toenails and do a head massage?
I don't want my toenails painted. Blue.
Squeeze.
Greeny blue.
Green.
Green. Not grew. I've got £73 in Royal Bank rewards.
What's that mean?
It's a benefit, not cash back. It's a benefit of my account. Well, technically, yeah, it's cash back. On any utility bills that get taken out of your account, you get like 2% back or something. When I always forget it's there, it's been building up for like 14 months or something like that. 15 months. 73 quid. I've been using Top Cashback as well.
Oh yeah, you've got to put some good money in there now.
Well, I've got some money.
Yeah, I've got that actually. There it's on.
Fucking shit. Oh, I've got £14.31. Yeah. So
I don't know how much I've got.
I got 1% back at Screwfix and I got 4% back at Tool Station.
Better than like I said. I've got 130. 120 payable and 10 pending. And I've got £100 in my Vinted.
I've got about £1,000 sat in the living room waiting to go on eBay.
Yeah.
That's gonna be my income for March. At this rate.
Yeah. Okay. We've got no plastic cheese. I can do it with real cheese. Got red Leicester.
There's some of that black bomber left. Found that in the back of the fridge. What?
This room didn't have a waiting room.
Have you disabled it?
No, I've just put them back in there. They just draw on white space. This one.
Enable waiting rooms too.
Yeah, no, it is now. It wasn't.
Hmm.
Did you see? Sorry, I missed your reply on the cheese.
So we've got
That one.
2 seconds. Hello, mate. Here we are. Last one of the day. I know. So that'll be session 5.0. Yep. Yeah, no worries. I'll certainly take a look at that. I'll make a note of the session number 5.0. To be honest, things like that, I really wouldn't worry about it. It's all part of, the natural course of human interaction. If we were in a room, we certainly wouldn't think, twice about it. We'd just, pick up and carry on. Oh, fantastic. You know what? Diving's the one thing that scares me to death, to be honest, because I'm not the strongest of swimmers. But yeah, diving fascinates me, but it really does scare me. I'm more of a climber and a walker. And in fact, for my birthday next year, I'm planning to treat myself to a trip to Everest Base Camp. That's my challenge for next year. It's easily done, but it's not a big problem really if it happens. You may have just hit the admit all when you were trying to select a name at the top. It's easy to slip. I've done it myself many times, in much more consequential circumstances than this as well, shall we say. But it is what it is. Absolutely. Well, I'd be lying if I said I didn't find it nervous on day one this year. It had been such a stretch since we'd done this, and virtual conferencing like this is on the decline slightly. It's not as busy as it was a couple of years ago, let's say. So my experience is a little bit rusty, but it's all part of the fun. And thankfully, you guys at GSE are a wonderful bunch of people to work with. You're all very, very nice and kind. So that certainly helps and makes it a much more pleasant experience for us as well.
Good afternoon, Andy.
Absolutely. I certainly think there's a market for it for GSE, definitely. And yeah, it has. It's been an absolute pleasure. And your new device sounds absolutely perfect. It's really nice. Oh.
Easily done. I'm all right,
Yep.
thank you. And last session, I can't believe it. It's flown. It has. It's absolutely flown.
Really?
Am I right in understanding your chair in this session? No problem.
Mhm.
Well, I'm happy to make you host. If you need any support, if you want to make me co-host again, I'm more than happy to keep an eye on it.
Oh, okay. Yeah, very interesting.
Yes, if I'll make you a host, and then you can give me that co-host.
Absolutely. Well, it's something similar we'll look at for the live conference next year if we do virtual as well. But conversation for another time. I'll let you guys get on and get sorted. Have a great session. Cheers.
No problem at all. I've just got to go and let some more people in to some of the other rooms, but I'll be back shortly. No problem. Bye. Hi, Jamie. Last session. No, it really is. I can't believe it's the last session now. It's flown by. Hi again, Chris. Good, thank you. Room's all yours. Sorry, room's all yours. Have a great session. It's all weird.
Why?
It's like muting me and kicking me mid-sentence and things like that. Right, Yara. Last session, we've made it. Have a great session. It's really weird. I can't think what's happening.
Might need a reboot. We're nearly there.
Hi, Stuart.
Home stretch.
Yep, the end is nigh.
It certainly is.
Just to say, for session 3P and also for 3N, I had a bit of a discussion with the speaker at the end that's not for publication, for publicize, that word.
Okay, it's for your eyes only.
For my eyes only, yes. But I had cleared all the speakers out, all the attendees out and everything. So I just hadn't actually ended the session at that point.
No problem at all. I've made a note of it. I will make sure it's cut off and not published with the rest of the session.
Thank you very much.
No problem. Hopefully this one is just as smooth for you. And just to say thank you. It's been a pleasure as always.
Yes.
Hopefully we'll do it all again in 6 to 8 months' time.
Yeah. Well, why not? Seems
Absolutely.
to go okay.
Yeah, it'd be rude not to.
Yeah. And thanks for everything from you as well. And
no problem at all.
I haven't checked with my colleague whether your hints to be able to change his name. I'm so surprised you were right. It was his daughter.
It's easily done, especially in shared
Yeah.
computers, and it's very frustrating that it doesn't.
Yeah, it
Doesn't-
shouldn't have been a shared computer though.
Oh, naughty. All right then.
Yeah, but also he really should have told me that that's what he was showing up as. So
Absolutely, yeah.
Yeah.
You can always
Never
rely on a
mind.
speaker to keep you on your toes.
You can always do that for sure. All right.
Have a
Thanks a
good one.
lot.
Cheers.
Cheers. Bye.
Bye.
Morning. You're muted, Anna, I think.
I am. Yeah. Okay. How you doing?
It's Thursday. Things are looking better.
Just Friday to go.
Yeah. Well, you don't work Fridays anyway, do you?
No, not with customers anyway.
Yeah, Butch should be joining in a second. He said he was.
Yeah.
He does the first part of this.
Okay, so you really need him to turn up.
Well, I gave this to a company in Malaysia yesterday, but I'd rather he do the first part here.
Yeah.
But just in case, I'll
You better check you can share your
I better
screen.
call up the presentation that he had, if I can find it. No, that's the other one, see? Yeah, I'm gonna ping him.
We've got 6 minutes yet. 5 and a bit. 5.
Well, he called me just to test his headset, so did he have any more bugaboos with your internet connection as you did the other day?
No, and actually there was nothing wrong with my internet connection. Everything else was fine, but I'd been thrown out of Zoom halfway. So yeah, so I just make everybody co-host now. I mean, not everybody, but the speakers, just in case.
Okay. Pinged him, but there's no response. I told you him literally 10 minutes ago.
Yep, looks like you better get prepared.
Okay, let me just mute quickly and try and.
Ah, who's here?
Oh, the prodigal son.
Hi, Butch. You should be able to unmute yourself.
There it is.
Yep.
Good afternoon. Good morning to Chris. I'm gonna say good morning just because I can.
I'm gonna say nothing ever good about mornings.
Well, it is for me. I'm technically on vacation. I'm taking a little a 1 hour out of my vacation to give this presentation. Just because I'm a
good
nice
chap. What a good chap you are. Yeah.
I'm a nice guy. I didn't want to dump it on Chris like this. So
He was getting a little worried, to be sure.
he and I were just talking.
He has the presentation pulled up on the other screen just in case. So.
Okay, so if you can check that sharing's fine.
Let me share my screen.
And then you also need to decide if one of you is going to be keeping an eye on the chat for any questions.
Yeah,
I'm doing that. I'm keeping an eye on the chat while he's speaking.
Okay, saves me doing it.
Yeah.
Okay, you all see the presentation?
Yeah,
I can indeed.
A good deal. I think we're good to go. I'll just leave it like that, if that's okay.
Yeah, sure. Yeah, you can do that. When I let everybody in, I usually just pause quietly for a bit because it does take a little while for them to actually get in. So if I start talking right away, they join in the middle of my sentence. So and it's a nice quiet pause for the tech guys to know this is the start. So that's fine. And I'll let you introduce yourselves. I'll just mention the major topic and the session identifier and about doing feedback and the fact that they will all be on mute. So if they'd please put their questions in the chat. I think that's pretty much everything to just check with you. As you're going to watch the chat yourself, I don't have to ask whether I need to break in, so that's even better. And we are starting to get some people in the waiting room, so that's also good. Less than a minute to go. Any questions?
No, I don't think so.
Good. That's what I like.
We're getting to be old hands at this. So.
We are. Oh, 15:30. So I shall let people in. Well, let person in. So no, my person went.
They left.
There's nobody here. Oh goodness. They were there. They must have got fed up with waiting, but it's literally only time now.
Yeah.
Heck. Okay. Well, because these will be available in replay, we'll go. Oh, they came back.
They came back. Yeah, there you go.
Yeah, I'll admit him this time. Maybe he thought there was a problem. Okay, good afternoon. Welcome to the final session in this track, just the keynote to go after this one. This session is provided by Butch and Chris. They'll be talking about batch resiliency for ZOS systems. And please remember about feedback. There's the QR code here. I will put a link into the chat. And of course, you can access your feedback from the Bring Your Own Agenda for each of the sessions. It's easy enough to click on that. We do use the feedback, so please make sure you provide it. You are all on mute during the session, so please, if you have any questions as you go along, pop them into the chat. Excuse me, Butch and Chris will be watching out for any questions that show up so that they can answer them as we go along, or we can have an open Q&A session at the end. Thank you very much, and over to you, Butch and Chris.
Thank you, Anna. My name is Butch Rambish. I'm the product manager for the Security and Resiliency suite of products from 21st Century. Chris Taylor is our technical sales executive. He will be doing a live demo after I go through a few slides. This is a product focus or product spotlight. We're going to be talking about an IBM product. 21st Century is a development partner for IBM. So what we're talking about is an IBM product called IBM Z-Batch Resiliency. It really is a one-of-a-kind product. There really isn't anything like it out there, and we're going to talk a little bit about why customers would need this, and then really focus on what the product is and what it does, and Chris will really tie it together in a nice demo at the end. If we do mention any futures in the presentation or in the discussion or answering questions, our answers and what we say is our best information we have today, but as in any product, things can change when they come out. So when we look at operation resilience, just resiliency in general, we typically think of our disaster recovery scenarios, our disaster recovery testing, and we've been doing that for decades. I mean, we've done a fairly good job. The problem with our disaster recovery testing, though, is it really is focused on, well, I just need to get my data center is down. I need to get it up in an alternate location. Very few people have really even tested a true disaster, because most disaster recovery test is based on quiescing the system or a quiesce system and then bring it up fresh. And yeah, we brought it up. Yep, we got CICS up. Yep, we got DB2 up. All of these things, yeah, we check the boxes. And that's what disaster recovery and operational resiliency has become, is really checking some boxes to say, yes, we can get our system up and running. But I would challenge anybody that says, well, that's good enough. Go out there one day and press the red button in the middle of the day and see if you can recover. That's the true test of operational resiliency, is when things go down unexpectedly, can I recover? Whether it's the whole system or whether it's an application, rarely are those incidents going to be started by a smooth takedown and then a smooth bring up. It's going to be a hard and fast crash. And you know, when you look at things like the DORA initiative out of the EU, the government regulations are beginning to catch on to this checkbox. And if you look at some of the requirements of DORA, it really is around ensuring that you have operational resiliency. You know, so they have very specific things that you have to show that you can do, and it really is geared towards a true operational resilience when something goes down very quickly. Now, when you're dealing and trying to improve your resiliency and you're trying to do all this, you can't just throw everything out and start over. You have a business to run, you have applications that you have to continue to operate, and you can't just kind of just go stop everything and reinvent it. You kind of have to modernize your resiliency and run your business at the same time. And that's really the challenge as you move forward and modernize. The whole time, the threats to the business are increasing and time is of the essence. You have to get things up and running quickly when there are outages. And it gets compounded, the complexity is compounded because of data dependencies. Gone are the old days when I was a young systems programmer, when each application had its distinct set of data and there really was no interrelationship. Today, across almost every organization, applications are no longer that independent. They are tied together by the data. You think of a large bank, a customer record is not used only in one application. It's used in any application for the different accounts and applications. Things like that make recovery and operational resiliency more challenging. One of the approaches that a lot of organizations make is, well, we'll just take a lot of backups. We're just going to make backups and copies of everything. And they do it typically with usually hardware solutions, taking volume level backups. But those backups don't have a data set level insight. They don't have the perspective of the actual application, its data sets and data set usage. It's just, I'm gonna back up this entire volume. I'm gonna back up this entire set of volumes. I'm going to replicate everything. All of those things are done really without any data set level insight. And all of those practices and just about everything that are in use today to improve resiliency and do disaster recovery, they're largely manual tasks. There's very little automation. And anytime you have manual tasks, you have the lack of information and analytics, you got decisions made in the dark, and it just increases the time for recovery. Now, when we look at the IBM Z platform, one of the things that we can safely say is our availability is better than any platform out there. And we're proud of that. I'm an old mainframe guy, and I really am proud of the platform, having been involved with it for 40 plus years now. But at the same time, that availability does not guarantee operation resilience because of the lack of data set level insight. And that's what we're going to talk about today with IBM Z-Batch Resiliency. It's a product that is designed to bring automation and data set level insight to give you true operation resilience for your applications. The ability to ensure that when you have the operating system up and running, that you're able to get your applications up and running as quickly as possible. If you have just an application outage, that you can quickly identify what are the backups available and how do I get this application up and running. So we're going to talk about operational disaster recovery as a solution from IBM Z-Batch Resiliency. And one of the things we talk about when we're going through this presentation is we talk about protecting non-database managed data. And what is non-database managed data? It's pretty simple. It's pretty much what it sounds like. When you think of your databases, they have logs and journals, and they do a really good job of being able to recover. But not every bit of your data in the data center falls under that category. So if it's outside of your database, it doesn't have the logs and journals and the image copies and all of that stuff. That is what we're really talking about when we talk about non-database managed data. Your VSAMs, your sequentials, your partition data sets, all of those types of data are data that you need to have as resilient as your databases. So when we look at resilience and what a lot of customers are doing for resilience, they have all of these silos in their operations. You've got your operating system guys, you got your schedulers and your tape management, your database systems, your storage guys. All of these various things are used in their own way to enhance or improve resilience. But there's nothing that really ties all of this together, that brings these silos of information together in a cohesive way. And now we've added things like safeguarded copies, where we do the immutable copies on the DS8000 or a ZDP on a Dell EMC box. And that's another form of data. But again, it is not cohesively brought together in a way that is automated and improves overall resilience. So when we look at what IZBR, I'm going to use the acronym IZBR to refer to IBM Z-Batch Resiliency. And so when we look at it from an operational disaster recovery, this is kind of a high-level view of the architecture of the product. And it really starts with the application table. And the application table is derived from the scheduler. Almost everybody will restore to their schedule when they're looking at their batch work that runs at night. And most of the non-database managed data is really largely used in the batch environment. It can be used outside of batch, obviously, but largely it's used in batch. So we use the scheduler as a beginning point to be sure that we understand when a data set is accessed, who owns the data set, what job it is, et cetera. And that's in the application table. And then we have real-time data collection where we gather SMF data directly from the SMF address space. We use that to update an inventory, a comprehensive inventory of all the data set usage. And we also scan the backups for all of the critical data sets so that we know at any given point in time when a data set's backed up, has it changed since the last backup, and various other information that's needed. All of that is done in near real time. So within minutes of a job completing, all of the data sets that it used will be updated in the inventory. Any backups, if a backup was taken within minutes, it's going to be updated in the backup table. There's a lot of reporting. We'll talk about those shortly. And then we have a real-time component over here on the right. It's not based on SMF data. It's based on the open close activity, the open and close macros. And that is called Timeliner. And Chris will show you these reports later. But there are two main reports in the Timeliner. One is the forward cascade report. The forward cascade report, if I take a point in time, it'll show me every downstream job that is dependent on this particular data set. And it shows it whether it's in that application or even another application. So if you have to restore a data set, I can very quickly see what needs to be rerun in all applications that is based on the data that I restored, so that I can ensure that everything is in sync. The next report is the reverse cascade report. This is kind of a forensics type view. And I like to refer to this it's like if you're looking at your family tree, you want to go back in genealogy and you want to look at your grandparents and your great grandparents and so on back through time. Well, that's what the reverse cascade report does for the data. And so it's like looking at your schedule, your scheduler, the predecessor jobs, but instead of looking at it from a scheduler point of view, it's looking at it from a data set point of view. So if I look at a particular job and step, and it'll show me the data sets that are input and output, and then I can look one step back and say, well, what data sets for these input data sets, where'd they come from? Then it'll show me the previous job where maybe they were an output data set, and it'll show me what the input data sets to that was. And I can go back through time and see all of the related jobs based on the data. So it's giving you a data set perspective to your schedule. It's a very useful tool. And then we have the backup table inquiry panel, the ability to see all the backups, and we can actually put an R next to a data set right there on the display and restore the data set. One of the things that IZBR does that's really helpful, we're seeing a lot of organizations that are telling us, their people are retiring and they're not getting as many people back in. They have a lack of technical skills. A lot of the skills and expertise have left. And one of the challenges is just getting people that understand how to do JCL, how to do the backup utilities. And we use these driver templates to simplify the restores and backups for your environment. And so you can very simply select to restore a data set, and instead of having to know all of the control cards in JCL, it knows what the backup it is, it knows what utility was used, and they answer a few simple questions, and it'll generate the JCL to restore the data set. Very simple, very easy to use. It allows operation analysts, application analysts to very easily restore data sets without calling in a storage administrator to run a restore. A little more information on the app table. If you're running IBM Z Workload Scheduler, we do have a dynamic application table interface that allows us to capture not just the schedule, the forecast that comes in the morning, but if you have any ad hoc jobs, we'll capture those as well. But for all job schedulers, just about every common scheduler out there we support, and it basically uses a batch interface to update that application table on a daily basis. Our real-time analysis, I just a little more detail on that. We read in a variety of SMF records. This is most of them. That's not all of them. There's a few others that aren't in that list. But we read in these SMF records directly from the SMF address space, pass them to our real-time analysis, which is a started task that is going to take that information and use it to update do all of the analytics, curating of the data and getting information in the critical file list. It does some analysis to determine what is a critical file. So the critical file list is really a derivative of the entire inventory, and it's a list of those files that are critical to operation. So this is the list of the subtasks that are running in that started task. This started task is very efficient. All of these subroutines are written in assembler, very efficient. Uses usually less than 1% of the CPU, even on larger systems. But the point here is that it is very efficient, but we're processing all this information in near real time and updating the system. The critical data sets, this is something that is automatically determined. You don't have to go through and say, well, yeah, I think this data set's critical and I think this data set's critical. We look at the criticality of the data sets based on the usage patterns and when they're backed up, when they're created, and we can look at a data set and determine, how critical it is to the operation. And really what it's looking at is any data set that cannot be recreated in that cycle is critical, and it's going to ensure the system helps you to ensure that you have backups for all of those. Now, this is a report that came from an actual customer. That's why the data set names are redacted, because it is an actual report from a customer. But the information on this particular report is very useful for each data set. It shows you what its status is. And Chris will talk a little more about the status in his demo. It shows you the first access job, the DD statement, whether it was input, whether it was output, and all of this information is useful to help you understand better your applications and what's necessary to keep them up and running. We do keep track of every backup. We know what backups are taken. We know who's taking them. We know what time they were taken, and we can show you reports that show you if you have data sets that are backed up multiple times. Sometimes they may be backed up by multiple applications. Which is the best backup? Are they even being taken at the right time? And we also have critical, if you have critical tape data sets on virtual tape, a lot of time that's overlooked, and people don't have backups of their virtual tape data. And it's another form of critical data that if it goes, you are not able to restore or to get your application up and running. Here's another actual report from a customer. It's showing the status of the backup. And so here we can see this backup that's highlighted in orange. We can see that there has been a change for that data set since that backup. So it was backed up at 2200 on 4/16, but at 2259 there was another job that made a change. So if I was going to back up or to restore from that backup, I do know that something else is going to have to run after that because it's changed. Or in this case, I see there's a more current backup where nothing's changed, and that would be the one I would probably restore from. So our backup table, I already kind of alluded to this, but a little more detail. We do track every backup. You can track backups whether they are using tools like DFDSS or FDR, or if you have utilities like IEB Jenner or Repro with ID cams, or even user-defined backups. All of these can be scanned or monitored, and the backup table will have the most current backup, so that when you go to restore, the system knows which utility was there and it knows how to restore that data set. Now, we don't track DB2 and IMS backups in the backup table, but we do provide some reports that show if you have some table spaces that are not being backed up with image copies, those can be flagged in reports just to give you some consolidated resiliency reporting if you need. And then what we call the worst case scenario backups would be your cyber vault, your immutable copies. Those aren't really designed to replace application backups, but really are to be your worst case scenario. And we have a facility called the 3D Virtual Catalog, which I'll describe shortly, but it's a way of ensuring I can find a data set in any of those immutable copies, safeguarded copies, or ZDP copies. Okay, so a little more detail on the reporting. There are a lot of reports in the product, and when you look at a DORA, for example, the legislative requirements out of the EU now, and I know in the UK, this is becoming a large impact because a lot of financial institutions that do business in the EU have to adhere to it just as much. And that EU is going to require reports that show that you have all of your critical data sets backed up. It's going to show that you can restore them. It's going to show if you're missing backups. So a lot of these reports provide that kind of information. So if I want to know what critical data sets aren't being backed up, we have a report that shows that. If I need to know what are my application dependencies, what applications use this particular data, or what data sets are used by multiple applications, I can see that with the cross dependency report. We have some audit reports that are very useful. So looking at data sets that are accessed by jobs or users outside of production, outside the scheduler, we can see that as well. And there's a lot of reports that are available. IZBR, some of the audit functions, it is constantly looking for new critical files and can flag them for backup by default, or at a minimum shows in a report. So when the auditors come looking and they want to see, are you backing up all of your critical files? You will know without a doubt that you are backing up all your critical files, because IZBR can monitor for new ones and let you know when there's a backup missing, and you can take care of that before the auditors come in looking. Again, looking at non-production jobs, you can make sure that you don't have any of those updating production, and a lot of other useful information for audit purposes. Here's an example of a report from an actual customer that shows data sets accessed by jobs and users outside the scheduler. And it was interesting because this particular customer, surprising enough, they actually had over 600,000 critical data sets that were identified as being read or updated outside of the scheduler. I don't think that's something most auditors would or even security analysts would care for, because it makes it very difficult to manage your resiliency and your security if you have people outside of production doing that. The application dependencies, we've talked about this already. They are growing more complex, and they are an inhibitor to your resiliency, because if you have one application goes down and you restore a data set and you get that application up and running, if you don't know about the dependencies, you may have another application that's completely out of sync. The reports aren't going to balance. There's going to be a lot of problems downstream, and it's going to just make it that much more difficult, because now I have to go work on another application. I have to figure out, where did it go bad? Oh, it was because this other one got restored. So understanding these application dependencies is absolutely critical to operational resilience. Again, another real report from a customer. The data sets are covered up because we don't want to show their name. But it was interesting when we looked at the statistics for this particular customer. They had over 401, almost 402,000 data sets that had dependencies with another. And of those, 55,000 of them were critical data sets. And so if you have to restore one of those critical data sets to restore an application, it would be absolutely necessary to know this and be sure to keep your environment in sync and running. The other thing you can do with the data is you can offload the data in a CSV file. This is one report. I'll show you another one after this. Just some examples of some reports that customers generated with Excel by offloading the data. This one is looking at the backup table insights, number of backups per day, and some other reports. Very, very easy to do and handy when you have to do management reports. Managers probably don't want to see the tabular reports, but you can give them some nice graphics. One of the capabilities in IZBR is the real-time schedule. And the real-time schedule evaluates the scheduling events and not your IZWS scheduler or your CA1, your CA7, I think it is. Anyways, the other schedulers, but looking at real-time schedule events from the perspective of your data. So it's looking at the data and understanding when is it used, when is it not used. And so it allows you to look at the data sets and know when can it be backed up, when shouldn't it be backed up. It understands the data set usage and eligibility through the day. We've actually used this to feed encryption projects where they're using ZDMF to encrypt the data, and they'll use this real-time schedule to say when's the best time to encrypt the data. And we also use it to actually optimize the backups for customers to improve their batch window. Most customers running batch 24/7, and you can actually reduce your batch cycles by scheduling your backups when it's most appropriate for the data set. And the real-time schedule is designed to help with that. This is a graphic that kind of gives you an example of what that would look like. So in today's environment, you run your applications, and most companies run a backup at the beginning and at the end, or at least at the end. And the total of your batch window is going to be the sum of your longest application and backup window. And what the dynamic scheduling capability using the real-time scheduler does is, instead of waiting and running all of your backups at the end of the application cycle, it actually will mark when a data set is eligible for a backup. And you can have IZBR, you could say, I want to run a backup every hour. And each hour it will look at the data sets that were marked as eligible for backup, and it will back up the data sets at that point in time. And so then when you get to the end of the last application, really once the next hour hits, it will finish the backups, and it can greatly shorten the batch window. A couple of reports that just kind of show how that plays out in terms of the number of data sets and the amount of space that's being backed up. This is just a simulation that's showing by 2 hour period how many data sets and how much data would be backed up. We do keep track of all of the statistics on the data sets, what media it's on, what its allocation criteria is, all of that stuff. And we also know if something is on tape or virtual tape, and we can help you to ensure that your virtual tape is in sync in the case of, if you do have an outage and you have to go to your secondary site, we can tell you whether the data is in sync or not, and help you to ensure that you can recover. Ultimately, what IZBR is there is to help make your recovery easier. So, here the little guy on the left, he puts an R next to this data set and presses enter. It's going to ask him a couple simple questions. It gives them the opportunity to restore it to a new name. It's questions about replacing JCL, etc. And when they press enter, it's going to generate the right JCL and control cards for that particular backup. If that backup had been an IDCAMS repro, it would have generated an IDCAMS repro JCL and control cards. And so the user does not have to know all of the utilities, all the control cards, all the JCL. The system knows that and generates that. Timeliner, I introduced it earlier. It is based on open close activity. It does use the application table. It's going to store information in a Timeliner data set, and then it journals that information out, and does provide a real-time, up-to-the-minute view of all of the jobs running and what files they used, et cetera, and shows how they relate to each other. So what that means is if you had a application corruption at 1 in the morning, I could use the reverse cascade report that shows me all the jobs and steps that updated that effective data set. And that'll help me find a point where I can restore the data set. So very quickly get to the restore point. I put an R next to it, I restore the data set, Then I can use the forward cascade report. It's going to show me every downstream job that was dependent on that data. And instead of running the entire schedule, I can actually run parts of the schedule and reduce the amount of time it takes to recover, as well as use less CPU time. If you had a hard crash, again, somebody not push the red button, but the red button is in essence, the system crashes. And I go to recover my system. One of the things you're going to need to know is what data sets were open, because if a data set was open for output at the time of the system crashing, those are the data sets that you're going to have to restore. And we have a DS active report that would show that. You could then restore those data sets and then use the forward cascade report to know what I'm going to have to run to get caught back up. There's some other capabilities. I'm not going to go through them all, but we do have some reports and other capabilities that are really useful. One of them I will highlight, we do have a DB2 table space report that shows the intersection between your DB2 system and your batch data. DB2 is not always only updated from an online transaction or directly from users, but often it is batch jobs are used to do mass updates. And so it's useful to know what jobs and what files were used as input to updating DB2. And conversely, if I restore a DB2 table, I would want to know what jobs downstream do I need to run. And this would be useful to show that. And we do support the Unix file system as well, which is another one that is becoming more important for a lot of customers. So, from an operational disaster recovery, IZBR is used to recover at the data set and job or application level. It's not just volumes. It gives you that data set perspective that we were talking about at the beginning of the presentation, that data set perspective to your resiliency, the ability to restore applications, because now I understand what data sets are critical to that application, when they're used, when they're updated, when they're backed up, and I know all of that information, and I can very easily use that to ensure application resiliency. Real quick, one other capability, I'm not going to spend a great deal of time on this, but just want to mention that IZBR also provides some cyber resiliency capabilities. There's a lot of work and a lot of talk in the environment about the immutable copies, the safeguarded copies, cyber vault, and all of those things. And IZBR is absolutely critical to the success of those, because again, most of those capabilities are based on a volume level approach. And you're going to need the ability to surgically recover data sets. And that's where IZBR comes in, is the ability to surgically recover any data set, not just non-database managed data, but any data set. But the problem with the immutable copies is there's a lot of them taken, and they're taken over time. And if I were to put all of the pictures I ever took in my life in a single directory, and I wanted to find a particular picture, I would have to go scan and try to find that. And that's kind of what it would be like surgically recovering. And so what IZBR does is we have this patented technology called the 3D virtual catalog. And the 3D virtual catalog allows us to be able to find a data set on any safeguarded or ZDP copy, as far back as they go. And the reason this is a problem is data sets are not bound to a particular volume. And so today I have my catalog structure, and I look in the catalog and it tells me this data set is on one volume. But because of the systems managed storage and just the life cycle of data sets, if I go back 1 or 2 or 3 copies, there's no guarantee that data set is on that volume. And if it's not on the same volume as the catalog points to it right now, it could take a good bit of time in larger shops to locate that data set. And time is of the essence. You need to be able to recover it quickly. And the 3D virtual catalog answers that problem by giving us the ability to know at any point in time where that data set is. And so this will be the last slide I talk to, and then I'll turn it over to Chris. But the IZBR, it runs in your production environment. It provides all of the things for operation resiliency. We were talking about gathering information, but it's also building that 3D virtual catalog. And so when you have a scenario like GDPS, for example, and they're mirroring the data and you're creating your immutable copies, you're going to run GDPS in your production environment, but in the Cyber Vault, you could use it to surgically recover any data set from any of the copies to help you to get your environment up and running, to do forensics or whatever you need to do in your environment. So Chris, if there's no questions in the chat, I'm going to turn it over to you to do an operational resiliency demo for IZBR.
There are no questions in the chat. Just like to remind people that if they do have any questions, please put them into the chat.
And when Chris is done, we'll pop back over to a final slide, and it'll give you your QR code again for your evaluation.
Okay, so hopefully got the right screen there. Otherwise, you're looking at my speaker notes. So as Butch mentioned, there's a lot of moving parts to IZBR. And the core of what we get the information from within the product is from the application table. We support, within IZBR, we support all the regular scheduling systems. And that is what is the core of the information that we use to determine what are production data sets, for example, what are production jobs, so that we can monitor what's going on in the environment. So from here, what I can do is then, as I can drill down and say, for example, this is a test environment within our lab. So there's not a lot of applications running. We have a regular suite of jobs that run. And from here, we can see, for example, with this particular application, it just lists out the jobs that are running, including which is the first job in the application cycle. So when we see this job running, then we will monitor this as a complete application cycle. And all the jobs under here will then store information, into our repositories, into the inventory, as well as into the backup table. And then also we have, this is also what is used to determine information that is then monitored by our timeliner function, which I'll also look at and talk about a little bit in a minute. So that's where we get that information from. Now, if you're running IZWS, also what we can do here is if jobs get added in an ad hoc manner to the application table or into the scheduler, then we can also monitor those, and they will also be tracked then by the various functions within IZBR. Now, once we have that information, as Butch mentioned, basically this IZBR consists of started tasks in the environment. There's an extractor that takes the information from the SMF address space, puts it into a data set which is then processed by the real-time analysis component, what we call RTSMF. Now, once we have that information from RTSMF, then we can start to look at more analytics into what's going on in the environment. So what I'm going to do is start out with our inventory, and I'm going to look at one of those applications that we were monitoring earlier. So I put in here that I'm looking at INSCT, and we can then see various bits of information regarding data sets that we used as part of this application run. One of the key pieces, and Butch said this is automatically derived based on usage patterns of data sets, is whether the data set is considered critical or not, and we associate a status with it. So in the case, for example, you see here that you have a status of 1, which is listed as critical. Well, actually, as far as IZBR is concerned, a status of 2 is also considered critical. The difference between a status of 1 and 2 is that with a 1, the data set was only read, it was open for input only, whereas with a status of 2, the data set was actually updated as part of the process as well. We call that an exception process. Not a huge fan of that particular description, but that's what we call it. And I look more at the status in this particular case. Now, the other options that are considered non-critical is a delete process. That means that the data set was deleted as part of the application cycle at the beginning, so it can be easily recreated. And then last but not least, we have a status of 4. And what that shows us is data sets that were created as part of this application cycle. This might be, for example, as we can see here, we have a particular GDG that was created and updated. So if you see in this file type, you'll see you'll see blank, which means it's a sequential file. You'll see P, which means it's a PDS or a PDSE. And then you'll see C for a vSAM cluster, and then you'll see G, which means this is a generation data group. And typically that would mean that underneath these are generation data sets that are then would be created as part of the application cycle. Now, if we move over to see some of the more fields, the additional fields available within the inventory, we can see, for example, the last time that a data set was created. A lot of these data sets are created as part of the application cycle. You see blanks here, it means it was created probably a while ago before the monitoring took place. Then we also have last reference date and last update and time, so we can see data set and usage patterns all across the board. And moving over further to the right, we can see sizes of data sets. In other words, what was the data set when it was created? What is it now? What was its low number of usage of kilobytes, and then etc. So that you can kind of get an understanding of how patterns evolve on data sets, as well as also when it comes to recovery time, being able to to determine exactly how much space you're going to need if you needed to do, for example, an application recovery. So from that, we also have, as Butch mentioned, reporting capabilities within IZBR. So from here, we can look and we can look at, for example, one of the key reports that we find is the cross-dependency report. Now, this will show me, for example, here, data sets that were used across multiple applications. So in this particular case, if we look at this IZBR demo.testing.reports, we have here data sets that were accessed by multiple applications. In this particular case, also updated by multiple applications. This is not a huge surprise. And if that's something I didn't really want to see every day, then I can also make customization to remove that from this report so that I don't see that all the time. At the top here, we see a data set that's used in an application that came in via an FTP process. Again, that's not particularly surprising. And again, that could be something that I could remove by customization so that I don't get that reported. Now, there's a number of reasons why this report is important. One of them is it is actually one of those things that when we go into a customer environment, bring this up for the first time, we more often than not would hear, why is that application using this data set? So that would be a sign that says, okay, maybe this is something where we need to split out and give application B a copy of the data set that's being used by application A, so that there's no cross usage of the data set within multiple applications. The other reason, and this has also been used by customers, why this is important here, we also have a variation of this report that we can use to determine if you are considering an encryption project, then it is important to know all the data sets that are using a particular, all the applications that are using a particular data set. Once you encrypt a data set, then you need to define the usage of that data set so that everybody can use it without causing issues. Because typically what can happen, and we've seen this happen, is that a customer might use a data set and encrypt a data set, and then all of a sudden 3 or 4 months down the road, a job runs at 3 o'clock in the morning, and it causes an add-in because it's not, according to the security product, it's not allowed to use that data set. So this is a kind of way of preventing that from happening, or lessening the chance of that happening by predetermining which data sets are being used by which applications. So after that will be the next stage that we look at. If there's no questions, I'm assuming there are none, we'll go and look into the backup table. Actually, I can see at the top of my screen whether anybody's put anything into the chat, so that's a good thing. So within the backup table here, what I can do is I'll look at a different application here. This is called, this is the INS application here. And what we can do is we'll see the various backup methods that I'm using. Now, I have a few backup methods that we use in our environment. We typically don't have too much tape attached to our systems, so we tend to do most of our backups to disk. So our backup method is primarily DSS, also known as ADR, DSSU. And what we also have is we have some sprinklings here of IBGener as well as IDCAMs, also in use here. Now, the backup table is constantly being updated, including, as Butch mentioned, the change dates here. So in other words, a backup was taken at a particular time, and then this was taken on, for example, on the 8th of February, and then it was because this is in Australia, so this was then updated on the 9th. So those are the kind of things that are being monitored. And over further to the right here, we can see when a backup job was performed, and also where that backup was stored. So in the case of a DSS backup, for example, the data sets get written, the individual data sets get written into a backup data set name, which I refer to as a container file. So there's multiple data sets that could be backed up to this one individual file. And that's typically something that you can't see easily without actually drilling down to the job in DSS and then seeing which data sets were processed at that time. This stores all that information, gives you where is it residing, where does it live, as well as also where was it backed up to. In other words, here, if I was backing up to a tape, I'd see a different device type, as well as a different volume serial number. And from that, what I can then do is I can go back to the beginning. I can then type an R, as Butch also showed, next to a data set, gives me a panel from which I can then recover a data set from a DSS copy by specifying a new name. That's typically what we would recommend, so that you can basically perform an analysis between the old copy and the new copy and see what the differences might be in the case of a corruption. And then that would aid with forensic analysis in that case. So after I type in the R here, it will then generate the JCL for me, including the correct vols here. If it, for example, not so critical if it's a disk data set, but if it's a tape data set, this could be something that may not be stored it might be something where you'd have to go back to the tape management system. And this all takes time, and time is the enemy. We're trying to get data sets back as quickly as possible. That's one of the main reasons why you would implement ICBR. So from here, what we can do is we have the restore of the data set, and then all those wonderful DSS statements that you would normally have to open up a manual or go to a storage team to get that information. It renames the data set with a new name. If necessary, it replaces that data set. And these are all statements that can be edited on the fly before submitting the job. So if we look, for example, at an IBGener data set here that we have a few copies of, I can say I'm going to go back a couple of days. I'm going to type an R next to it. And again, you're going to get a similar look and feel here. I'm going to recover it, go through the recovery process, at least to build a JCL to say, okay, from here, it generates the JCL necessary to be able to do a recovery from an IBGener copy. So first of all, it deletes the data set because I asked the data set to be replaced, the output data set. It then has to pre-allocate the data set because this is unlike DSS. There is no control information that's stored about the data set attributes. We have that information stored within the backup table as well to be able to recreate the data set. And then the last step would be to actually populate the data set from the IBGener version. Now, from that, we also have various reports that are important. And again, this goes into the legislative regulatory design here, for example, with DORA, to say, okay, make sure that I have backups of my critical data sets. There's reports that are generated here. We have shows the dates of when the latest critical files were backed up as well. As also, we have a report that shows me where critical files may not have a current backup. Now, I demoed this to a customer in Malaysia yesterday evening, and I did have one of my key data sets that I would normally expect to have a backup. I did see that it didn't have the backup, but in the meantime, overnight, when our jobs ran, then a backup was taken, so that's now no longer a problem. Now, in this case, this application called FTP test, I do not take backups of those data sets, so it's not really surprising that there's nothing here. But this, for example, in the case of key applications, would be something where a list could be generated and could be sent to those application groups so that they can then make sure that the data sets are backed up. Now, also mentioned earlier on is the fact that IZBR can then also generate the statements necessary to pick up the data sets that we were then going to process. So in other words, it's not a question of you having to manually go through and add data sets to those selection lists. That is something that IZBR does as part of its process on a daily basis. Okay. One of the other things that is important is, we've seen what happens if we're missing backups. What about if we're taking too many backups? And that can happen. We have in our environment as a test, we show here that for example, 4 backups are taken in the space of 15 minutes on one particular data set. Now, this is using extra processor. This is using CPU cycles. This is also using space on disk or on tape to store those backups. And then also the last part of this complex, adding complexity to the recovery process. In other words, if I have 4 backups that is taken within 15 minutes, which of these ones do I need to go back to in case I need to do a recovery? Those are all the kind of things that we can prevent here by, there's a feature within IZBR where we can switch it on. It's called Cross App, and it will only take one of these, one backup instead of all of these 4, and that would then be the one that could be used, for the recovery purposes. So a couple more things to show you that we have within the environment is one of the important reports that we have is something called an audit check. And Butch kind of alluded to this. This shows me where applications.
We have a question coming in, Chris.
Okay.
Go ahead, Ahu. You can pose your question.
I'm not sure if he's allowed to unmute, Butch. What's the question?
Let me see if I can unmute. Anna, can you unmute Ahu for a question? Since we have a small audience.
Sorry for interruption. You can continue and I ask later, but I wonder is there any support or functionality for mainframe cloud backup solutions? Like if we don't use traditional DFDSS backups, if we use, for example, we are working on Model 9 project. I don't know if you hear before, and I had a chance to implement the IBM Cloud Tape. If we use this kind of cloud backup solutions, how is ZBR work with this kind of cloud backup solutions? My question is about that.
Okay, from a Model 9 perspective, that is something that is being investigated, how best to support that. Because Model 9 runs in its own kind of environment, yes. That's something that we're looking into, how we might be able to support that. That's something that Butch as product manager will note, and we're looking into that. I know that we've had the discussion before, but right now it's more of the batch approach to things, because Model 9 is more of a started task that then determines what to write out to tape or out to the cloud rather. Okay.
Thanks. Okay.
Right. So we've got about 5 minutes to go. So just quickly to this audit check. This shows me a list of critical files that's being referenced by outside of the application table. This could be the first example of malfeasance of something not right going on in your environment. Maybe this could be a genuine thing, or it could also be that somebody's actually trying to do something that they're not supposed to do. And as Butch said, if you had the 500,000 or 600,000 jobs that we're referencing, from outside the application table, that's probably not a good thing, and your auditors are probably going to want to know about that. Last but not least, what I want to show is our timeliner function. Now, within timeliner, what we have here is this is an absolute real-time product, in that we can actually see if any data jobs are actually active in the system at one particular time. Right now, we don't have any jobs. I was hoping that we had something, but we don't have any jobs active in the system. But what I can do here is I can go backwards in time and forwards in time and look at what happened in the environment and get a better understanding of you know, what's happened, and maybe be able to do more constructive restarts, or you know, in order to be able to do a more targeted approach to reruns of jobs that are necessary. So if I do what we call a forward cascade report here, or normal cascade report, this will show me the anchor job that I'm using in this particular case is INSCT 004, and then will show me any subsequent jobs run, including any data sets that were created using data sets that were referenced within this job stream. So here we can see a number of jobs within the same application, and then later on we can actually see here, for example, a different application is running jobs using some of the input data sets from this application. So that allows me to say, you know what, these are only really the jobs I need to run if I have a problem in this particular INSCT 004. Now, conversely, what I can do is I can go backwards in time, and I can see, how do we get to this place? In other words, there's a problem in INSCT 004. How do I get back in time to see maybe where the problem occurred in the first place? So starting from here, we can see that this originated as an FTP process, either from another system or from off platform, and that's where we got into you know, into the current state and of the data set. Now, the other thing I can do here, similar to what we looked at in the backup table, if I want to then recover a particular data set, I can then also type in R, and we're back into the same kind of scenario where I get a list of the backups associated with that particular data set, including if they've been updated or not. I can select one of those versions, and then we're going back into the same kind of dialogue that we had earlier on. I think that's pretty much, looking at the time, that's pretty much what I wanted to talk about today. So I'm going to turn it back over to Butch.
Okay. Just real quick, wrapping up, you know, Chris and I were attempting to show that IZBR is there to help provide a level of operational resilience for your applications that you really just don't get with a volume approach. Giving you the ability to give a data set perspective to your resilience, your application, being able to see what data is needed, where it's backed up, when it's backed up, and allow you to be able to address auditors with things like DORA and other legislation that is bound to come out from other governments, and bring a level of automation and analytics to your approach that allows you to recover very quickly. The presentation, when you get it, there's some reference material here you might find useful, especially with some of the newer stuff around cyber resiliency. You might find some of that reading helpful. We've tried to address questions. We appreciate you being here and listening to us as the last session of the day. And just to reiterate what Anna said up front, please submit your session feedback. Here's the QR code. Our session is 3Q, and we look forward to getting your feedback. We will be presenting at future GSEs and have updates on this topic, and hope to see you in a future session. Thank you so much. Anna, I'll give it back to you.
Okay, so I have made it so that everybody can unmute if they would like to ask a question directly. That would be fine. I have also just put the link to the feedback in the chat. Additionally, if you're in your Bring Your Own Agenda, there is a link there as well to provide the feedback. So we would like to see that. And if anybody else has got any questions, then feel free to ask them. We are not tied to finishing right this second. We can give it a few more minutes, not a problem. Okay, that appears to be it then. So I thank you, Chris and Butch, for your time. And also to anyone that's still here, thank you for attending. I hope you got some useful information out of that. Thank you. And
Thank you.
Good night. Just the keynote to go. Go enjoy it.
Okay, goodbye.